Hey everybody, welcome back to another video. Now today we have some very exciting updates on the Susan Shore DIY usage. Now before we get into those updates, let's have a little lesson of neuroscience. Now if you've watched my previous videos, you guys know that I talk quite a bit about something called AMPA receptors. Now a quick reminder, AMPA receptors receive excitatory neurotransmitters from the presynaptic neuron, which then are transferred to the postsynaptic neuron. So you can imagine these receptors as antennas that receive signals from the previous neuron or nerve cell and pass it on to the next one. Now we all know that the less amount of these receptors we have, the less strong the nerve signal is that is then passed further up the auditory pathway. Now the Susan Shore device uses the principles of spike timing dependent plasticity, ergo long-term depression, which basically means that the nerve cell feels that the connection, the synaptic connection between the neurons is not important anymore, and it launches the process of dephosphorylation of these AMPA receptors. What that means is the nerve cell, specifically the fusiform cell, and other cells that are connected to it, not only in the dorsal cochlear nucleus, but also in the inferior colliculus, for example, and further up the auditory pathway and anything connecting to it. These nerve cells, specifically in the dorsal cochlear nucleus, that are being stimulated, they receive this calcium signaling that induces this long-term depression, and that means that the dephosphorylation process is launched. Now what actually happens in dephosphorylation is there are certain phosphate groups that help anchor, so to speak, these AMPA receptors to the cell membrane. They're actually anchored by certain scaffolding proteins, but the phosphatices that kind of interact chemically with these scaffolding proteins, they actually weaken this scaffolding, as you can see here, and the AMPA receptor actually goes into the cell, or it's internalized. Now this process is called endocytosis, and this is actually an excellent paper up here. So if you're interested in this, definitely read it. It explains the process in detail. But so to speak, when these AMPA receptors are internalized, they are basically either recycled back to the cell membrane or they are sent for permanent degradation. Now, what actually happens when it's recycled, or why it actually gets recycled? Well, for example, these AMPA receptors are pretty tough. I mean, it's not very energy efficient for the nerve cell to constantly create them. So they can be internalized when the body realizes that, this connection might not be that important, but instead of permanently degrading them, and it can just keep them inside these they're held inside these sacs that are called endosomes. They're just basically holding the AMPA receptors and waiting to recycle them back or to send them to degradation in the lysosomes. Now, what actually causes them to go back? So, as I said before, for energy efficiency, they're not immediately degraded. So for example, let's say a person, after using the Susan Shore device, potentially partakes of some stimulants or just anything that affects the neurotransmitters like, like benzos, alcohol, antidepressants, anything like that. This can actually cause the AMPA receptor to be recycled back onto the cell membrane instead of being sent for degradation. And that's why in my trials, it's really important that everybody has a very strict regime so that this recycling does not happen. What we actually want is the total degradation of these AMPA receptors. And that means no stimulants, nothing that suppresses, nothing that has any effect on the nervous system whatsoever. But basically, if the body does not recycle them or doesn't feel the need to recycle them, it will send them for permanent degradation in the lysosomes. And this is actually the explanation as to why using the Susan Shore device will lead to permanent suppression of tinnitus, because the receptors do not get recycled back. If you use the Susan Shore device correctly without partaking in anything that affects your nervous system, eventually these AMPA receptors will be degraded in the lysosomes permanently. They'll be dissolved. So that means that you will basically return to being like a normal person, and hopefully the homeostatic plasticity will eventually recover all of the ion channel dysfunction and any other problems that we have, or people with tinnitus have. Now let's move on to the exciting updates. Now, as you can see here, I got two messages, or groups of messages here. Now this guy is called, or we call him Guinea Boy because he's experimenting on himself like a guinea pig using the DIY Susan Shore device. And after he switched to a different audio for his Susan Shore device, one that kind of follows my my methodology of audio more closely, he got total, complete, full suppression of tinnitus. Literally, it's just absolutely gone. It's not there. He can't hear it no matter how hard he tries. And another thing that is really huge is actually his distortions, or Dysacusis, is gone as well. So Dysacusis is generally believed to be, I guess, partially involved in the inferior colliculus, which is actually further up the auditory pathway than the dorsal cochlear nucleus. The inferior colliculus is responsible for processing the sound that, or I guess the signals that come from the dorsal cochlear nucleus. So this is actually testament or proof that the Susan Shore device will cause a ripple effect of decreased hyperactivity throughout the auditory pathway. This is absolutely huge, because this means that potentially visual snow syndrome and Noxicusis actually could also potentially be treated due to their relation to the auditory pathway. And I don't know that much about visual snow syndrome. I will be studying it more, making a video about it. But from what I know, it is strongly related to the inferior colliculus and the medial geniculate body, which actually have a direct connection to the dorsal cochlear nucleus. And you can see that there is a direct output to the inferior colliculus and the medial geniculate body from the fusiform cells of the dorsal cochlear nucleus on this diagram right here. And just about the update itself, you can read it on the text on the screen, but it's actually insane that he says here that he's listening to loud-ass music. He's drinking a gallon of Mountain Dew, which actually has caffeine, which is a very, very strong stimulant. And his tinnitus is just not coming back. And his Dysacusis is not coming back. And it's you can also see here that, like, he says that he doesn't have to worry about it spiking or anything like that. But so far, his changes in tinnitus have been absolutely permanent. Without question, permanent. And generally speaking, guys, this is absolutely huge. I gotta say, absolutely huge for the Susan Shore device. It shows, or it means that related conditions absolutely can be treated. And it also proves the theory that these results are permanent, absolutely permanent. So I think that's about it for today, guys. And I'm really excited about this project. And definitely join my Discord channel to discuss anything related to tinnitus, hyperacusis, noxicusis, dysacusis, TTTS, and literally any other condition. That's it for today. See ya.